Hello, I'm Bhavani Charan Prasad. Today we are going to see a lecture on cracking. Let us first see the definition of cracking. Cracking is a process of converting high molecular weight hydrocarbons into low molecular weight hydrocarbons. This can be done by either heat or catalyst. In this process, we just convert the high molecular weight hydrocarbons into low molecular weight hydrocarbons. As an example, here you can see decane is taken, C10H22 is taken by applying high temperatures or catalyst on it. We are separating them into N-pentane C5H12 and another compound is the C5H10 pentene. So this process, conversion of high molecular weight long chain hydrocarbons into short chain hydrocarbons, this process is known as cracking. Let us see the importance or need for cracking. So we all know quite well that gasoline is the lifeline of world economy. From crude oil, what we will get from the crude oil is gasoline we will get, and some other middle oils we will get, and heavy oils we will get. And this is by the fractional distillation, whatever the gasoline we get is 20 to 30% only, and the middle oils 30 to 35% only we will get, and heavy oils 20 to 25% only we will get. As per the world requirement, world demand, we could not able to supply this gasoline, which is also known as straight run petrol. So this 20 to 30% cannot be sufficient for the world demand. That is what we need some other ways to produce gasoline. So we all know gasoline is mainly maximum demand for the gasoline arrived from automobile industry. So what we do for generation of this petrol here is we convert the middle oils and heavy oils into petrol or gasoline by cracking. So we already know that straight run petrol is the one we get from removing of impurities and removing of impurities of the petroleum and fractional distillation, and we will get the gasoline. Whatever the gasoline we get is called straight run petrol and straight run petrol. And there are other fractions as well there, like middle oil, heavy oil fractions as well there. These fractions are also converted into gasoline. This process is known as cracking. According to the world's demand, we are doing cracking in order to generate gasoline. So there are some methods are there for cracking. Methods of cracking there. Main method is going to be thermal cracking, and another one is going to be catalytic cracking. Name itself indicates that thermal cracking applies high temperatures as well as high pressures, and catalytic cracking involves catalyst. It involves catalyst, whereas thermal cracking is again divided into two different types. One is liquid phase thermal cracking and vapor phase thermal cracking. What is liquid phase thermal cracking? We are applying high pressure and temperature on the heavy oils and middle oils to get cracked. And vapor phase thermal cracking is where we apply high temperatures and high pressures on the vapor of middle and heavy oils. So, and catalytic cracking, we are as you know that we are employing what is called a catalyst here, and it is also divided into two types. One is called fixed bed catalytic cracking, and another one is moving bed catalytic cracking. Let us see one by one. The first one is going to be thermal cracking. So, as we all know, the middle oils and heavy oils are subjected to high pressure and high temperature without what is called a catalyst. So that what happened after the completion of cracking, so we end up with low molecular weight hydrocarbons. Already know we that there are two different types of thermal cracking. One is called liquid phase thermal cracking and vapor phase thermal cracking. In liquid phase thermal cracking, we apply almost 475 to 530 degrees centigrade temperature and high pressure as well, that is 100 kg per centimeter square is the pressure we applied there on the liquid phase of the middle and what is called middle and heavy oil. And these cracked products are separated in fractionating column, and whatever the product that is generated, whatever the gasoline that is generated by this method used to have octane number around 65 to 70. Whereas the second one, vapor phase thermal cracking, we apply more temperature, that is 600 to 650 degrees centigrade, and the pressure is less pressure, that is 10 to 20 kg per centimeter square. And the cracked products are separated in fractionating column, and the octane number obtained by this method is greater than 70. The another one is going to be catalytic cracking. In catalytic cracking, what we do, middle oils and heavy oils are subjected to low temperature, low pressure in the presence of a catalyst. Ultimately, we end up with low molecular weight hydrocarbons. As you know that there are two different methods are there. One is fixed bed catalytic cracking and moving bed catalytic cracking. So, in fixed bed catalytic cracking, what happened, each single time you need to add fresh catalyst to the reaction. In order to do reaction, you need to add each and every time you need to add fresh catalyst to them. So here we are using the catalyst as a silica and aluminum mixture, and zeolites maybe acts here as catalyst. Well, in this fixed bed catalytic cracking, we send this heavy oil or middle oil to the preheater. The temperature would be around 420 to 450 degrees centigrade. This temperature vaporizes these crude oil fractions, and later they will be sent to a catalyst towers. Within the catalyst towers, we place mixture of alumina and silica or zeolite as a catalyst. What happened in this catalytic tower, cracking takes place. So that means as we have already seen, larger hydrocarbons cut down into small short length hydrocarbons. Then once this process is over, and then these can be the small chain hydrocarbons are sent to the fractionating column, where we will get different fractions, and finally the fractionating columns fractions are sent into the condenser. Then gasoline is formed there inside the condenser, and then we will send that mixture to the stabilizer, where the degasification takes place, and we will get the pure gasoline. So, and another important thing is this catalyst towers are catalyst chambers, which maintain almost 425 to 450 degrees centigrade, and with almost pressure of 1.5 kg per centimeter square, the pressure being applied on it. And what happened during this during the inside the catalyst chamber is, whenever the reaction takes place, it also forms 3 to 4 percentage of carbon is also formed during while while cracking reaction takes place. This carbon fall onto the catalyst and covers the catalyst. The entire catalyst is being covered by the carbon, and this makes the catalyst it makes the catalyst inactive. So by this method we can able to generate 30 to 40% of gasoline. The problem with this method is every 7 minutes we need to stop this reactor, and we need to replace what is called catalyst. As you know, catalysts become inactive by the deposition of carbon on their surfaces, so we need to change for every 6 to 7 hours. So another method is there, the better method, that is called moving bed catalytic cracking, where we use it to send our heavy oil or middle oil fractions into the heater, which vaporizes, and send that one to the reactor. Send that one to the reactor. This reactor, while this reactor is added a powdered catalyst, a powder catalyst being introduced into the reactor in some another way. So what happened, the same cracking reaction takes place inside the reactor, and the same thing happened. What is that reactor, the catalyst becomes inactive, and whenever it becomes inactive, the catalyst is called as a spent catalyst, and that spent catalyst is sent to regenerated, and this regenerated by applying by applying air blast. It regenerates the catalyst, and the regenerated catalyst sent back onto the catalyst hopper, which is on the top of the reactor. Okay, and then the reactor, inside the reactor, we are all know cracking takes place, and that the mixture is sent to the fractionating column, and then after the fractionating is taken place, the fractions will be sent to the condenser, especially gasoline fractions are sent to the condenser, where these are cooled down and gasoline is collected, and a stabilizer would be there. That stabilizer degassing removes the gases from the gasoline, and we will get the purified sample of the purified gasoline there. And there are other reactions also takes place inside the catalytic chamber. Other than cracking, some other reactions are also takes place, like isomerization of hydrocarbons, and dehydrogenation of hydrocarbons, hydrogen transfer, cyclization, condensation, and alkylation, dealkylization. Several reactions are also there. These are all useful reactions we will discuss in the next video. Thank you very much. Thank you.